So it sort of makes sense that at some point Selenium will become asynchronous or allow us to do async IO web scraping using Selenium. But at this point, I've only found that Arsenic is a really good alternative to Selenium to run Chrome driver and actually do a lot of the exact same things in almost the same way. Now, I'm not going to be covering Arsenic in detail like I did with Selenium in the 30 days of Python, because I do think that Arsenic will change. And for me, this is not about doing asynchronous automation tasks, because I don't think you don't need to do that. I think doing synchronous automation tasks using Selenium is fine. Fine and actually really, really good. Asynchronous ones might get you into trouble because of how synchronous code executes and how fast things go and stuff like that. So we're not gonna really be touching asynchronous automations rather than just this scraping portion of it. Okay, so there's a number of imports I need to do here, but before I do that, let's just make sure that Arsenic is installed with pip install arsenic. Not the most friendly of names, but anyways. Okay, so now it's installed. And I'm going to do a few default imports here. And there we go. So we've got Arsenic and then a few of the other tools that I will probably end up using. So another thing I actually want to have in here is I actually want to write this to a file. So 2 parentheses here, and we'll call this write file, and I'll call this async scrape.py. Now, the reason I'm doing it in a file itself has to do with potential conflicts that Jupyter itself might have running this code. So that's because it's async and Jupyter itself is async. And so more than likely you could actually open up VS Code and do this part, or any text editor for that matter. But I can actually write a file in here, and I can also still run it with Jupyter, but it's just going to be a little bit different than before. Okay, so the first thing is we can actually scroll up a bit, and I'm going to copy the methods that I already had. So these 2 methods right here, and we're going to paste them down here. Okay, so I'm converting them into being asynchronous. Now the scraper portion, I'm actually going to move it down because I'm not going to do that one quite yet. But the extract ID and slug, well, to make this asynchronous, we just run async and boom. Now it's an asynchronous function. Okay, so not a huge deal there. Okay. The scraper function, on the other hand, is just slightly different. So what we want to do is actually use the services Chrome driver. So we first off say service equals to services.chrome driver. And that will initialize a Chrome driver much like this one. And just like what we had before, is we use the headless version of the Chrome driver, which means that the browser doesn't actually open up, if you didn't know that already. And what I want to do here is say browser equals to the services.chrome. And we're going to do Chrome options equals to the key, or the dictionary with a key of args and a couple args that we want to add in here, or arguments, headless, as well as dash disable GPU. Oops. We really don't need the GPU running at all, so there's no reason to have it. Okay. So this is the scraper right here. And what we want to do with this scraper is we want to, just like we did before, which was getting the URL, like actually opening that page and then getting the browser source, I want to do that same thing with my asynchronous call. So to do this, we use something called async with. So what async with does is it allows me to actually declare a session. So I can say get session, and this takes in service and browser as session. So it's similar to like with open, right? So if you've ever used, like I'm assuming you've opened a file before. So with open, it's very similar to that. Get session is just built into Arsenic, and that is a actual HTTP session or a Chrome session that's going to be able to be used. So similar to Selenium, we've got this driver here. This is actually running a session, and you can do gets and all that. We actually need to open up our session in this fashion. This is an asynchronous session. Okay, So first things first, we await session.get and our URL. Okay, so we absolutely need a URL here. So let's just go ahead. Well, I'm going to be passing a URL in here, so I'll leave that out for just a moment, but that's the URL it will actually grab for me. All right. And so that's going to give me that's going to actually do the URL change. Like it's actually going to get that URL. So to get the body data here, or the HTML body, we are just going to go ahead and say await session.get page source, and then we're going to return that body data. Okay. So now we have a way to extract a link and scrape that link. So I actually want to use that URL again. I'm just going to put it directly in this file. Let's go ahead and grab this here, scroll all the way to the bottom, and we will call it down here. So again, we're making a Python module here, so we're going to go ahead and say if name, and we're going to put this equal to main. We're going to add in that URL there. And we also want to get the event loop. So we'll say a loop async.io.get event loop. Okay, and now we're going to do results equals to loop and run until complete. And what we want to run until we complete is the scraper of that URL. Right? So I'm actually going to print out the body data. So that is one way to run it. So you can run it within the loop. You can also run it with, let's go ahead and say results equals to async.io.run, and also run it that way. Okay, so let's go ahead and test both of those things out. Let's run this cell. Okay, so it creates that file, async scrape.py. Of course, if you go back into your notebook here, you'll see it. So you don't have to run it inside of Jupyter at all, but I'm going to with !Python async scrape, hit run. And we've got a problem here. Haha, simple problem. It's outside of an async function, and that's because I never called this async. Okay, so let's try that again and run it. And I'm getting it has no oh yeah, okay. So silly import. This should not be services.com, but rather browsers.chrome. All right. And now we run this again. It loads up all sorts of stuff. So it's just logging out what's happening, which is nice. But it actually ends up getting to be pretty long, as you see there. So I will show you how to actually get rid of that in just a moment. But the main thing here is now we have that HTML body. So what I want to be able to do with that HTML body is actually get the same data that I did before, which was, grabbing the HTML like we did with these few blocks here. Okay, so what I'm going to do is I'm actually going to move this down a little bit. Delete that, and I'm going to put this entire thing into its own function inside of my new file here. Okay, so call this async def and get links of the HTML string or body. Put this stuff in here. Okay, so the HTML content or body content. So I put this in here. And I've got my extract ID slug, which is actually this one. So we would want to await that. And I can have this as blocking. I can loop through, and that's perfectly acceptable in this case. It doesn't need to be its own coroutine that's offloaded. It's called a future, but it doesn't need to be that. And then we can actually just return datas. Right, so to actually get those links and return them. So I'm going to make a new function here called run. It's going to change things a little bit. So async def run. Yet again, I'll actually take in that URL as an argument. And this time, what I want to do is actually get the body data. So body content equals to await scraper. Okay, so of course we know what this means. It's going to block this function. It's going to run scraper, get all of the things related to it, and return whatever that body data is. Okay, so after I have that body content, then I want to grab and extract the links. So I can say links equals to await get links from that body content, and then I can print out the links. And in fact, I'll actually return the links instead. And then now my scraper, instead of running scraper, I'll just go ahead and run. So let's save that, run that file, and let's scrape it again. Okay. So again, it's giving me all this log data. I'm going to show you a couple strategies on how to get rid of that log data. But it's actually really nice that it's showing me some progress here. Then eventually we will see. I don't actually know if I printed out those results. I did not. So let's actually run that again. Print out those results. But as we see here, only local connections are allowed. Chrome driver ran. Of course, if there was errors with Chrome driver, it would show us that. But notice at the very end, we have all those same kind of links. So that's close, but we actually want to store those links. So I'm going to go ahead and do async and define store links as data frame pickle. All right, so data's, and we're going to set that equal to an empty list, and we'll give it a name of, let's say, for instance, links.pkl. And so I'm going to go ahead and create a data frame from this. So pd.data frame, and it's going to grab that list, the datas, and then df.toPickle with that name. So toPickle, we'll actually save it as a pickled file so we can load it later. I'm actually going to go ahead and also say df.set index to the ID, and we'll drop the original one, whatever that might be. So drop equals to true, and then in place also equals to true. If I don't do in place, I just have to do something like that. All right, so this will actually store all those links to my data frame. This is more like store scraped data to that, but it's cool to see that we can do that. So now I can return the data frame. So df equals to await store links as data frame. We pass in those links, and now we can return the data frame. So the results now is actually a data frame. So we can data frame head. And of course, that's because this is returning data frame. If it wasn't returning anything, it's not going to, well, two things are returning the data frame in this case. But, if you don't actually return any results, you'll just get none there. And then this print statement won't work. Okay. So what we should see after I run this, well, first I create that file, and then I actually run the scraping. What we should see is a new pickle file in here appear, right? And I do. I got links.pickle. Right, so let's take a look. Name was links.pickle, pkl. So the data frame is pd.read_pickle and name, and then df.head. And there we go. And if we did df.shape, we can see how many rows we have. 84 rows and 3 columns. Why is it 3 columns? Well, ID is considered the index column right now. These are the 3 other columns. All right, so that's asynchronous web scraping with Arsenic, but we're not quite done yet. There's a number of things that we need to consider here. Number one, we only did one URL. That's actually not where the benefit's going to really shine. The benefit's going to really shine when we do more than one, and so we still need to do that. And then number two, how our actual data is being stored. This is fine for one URL, but we want to actually adjust how that works as well. So that's still what we need to do, and we'll do that in the next section. But the general idea is we now have a way to do web scraping using asynchronous code, which I think is actually really, really cool. So let's go ahead and keep going.